In the last class, we have just seen how do we create virtual machines using Azure. How do we create load balancer using Microsoft's Azure? Then how do we add virtual machines to the backend pool of load balancer, and how load balancer will distribute the traffic evenly between virtual machines. That is what we had discussed. I repeat, we are completely new, and it is absolutely fine that if we don't understand anything from yesterday's class, because that was just an overview of what you can do with a cloud, right? What we can do with a cloud computing platform at a high level. We are going to understand everything in detail starting from today. Starting from today, I'll come from the very beginning. I'll come from the very beginning. Now, question is, I guess most of you might be working in some or the other organizations, or you may have some understanding of how a real world project development happens in an organization. If I take an example, let's say XYZ organization has got a project from ABC client. Now this XYZ has hired or made a group of 10 developers to finish the given project. Repeat, XYZ company has got a project from ABC client. In order to complete the project, XYZ has hired a team of 10 developers and they have completed the project. Now, developers claim that the project is completed. But what happens in the real world project, real world scenario? You will have individual developers, right? So you will have individual developers. But how these developers maintain the source code, how these developers will have the database, how do all these developers will connect to the same source code, right? Same database, how the management happens, guys. There will be one server, right? Where they will have the source code placed, and they may use the same server, or there may be a different server. There may be a different server where the databases are created. If I just name it, this is, let's say, DB server. This is source code. This is a server where source code is there. This is the database server. I assume that these developers has completed the project development. Now this project has to be deployed. Like how we have deployed application and Angular application in our yesterday's class. Now the project that is developed by all these developers has to be deployed. Now what is needed, guys? What is needed in order to deploy the project? You have to have one physical machine. So there has to be a physical machine. Assume that my organization has spent some money and purchased a physical machine. Now, within this machine, what do? They install operating system. They install the operating system. After the operating system is installed, what do? They have to install certain dependencies. If it is a Java based application, they have to install Java runtime. If it is .NET based application, they have to install .NET SDKs or .NET runtime. So they have to install certain dependencies, and maybe a web server also has to be deployed. A web server also has to be deployed. On top of that, they deploy or they host the application. Same as, right? Same as the case what we have done yesterday. We created a VM, we enabled IaaS, and we deployed our application, our Angular application into that. Same case. This is the physical machine. Within the physical machine, what is being installed? OS is installed, operating system. On top of the operating system, install dependencies and web server. Okay. Looks like my voice is breaking. Is it the same for everyone, guys?
Not me, sir.
It's good.
Yes, it's breaking.
So what I do
Yes,
is
sir.
like am I audible? So we have to install the dependencies and the web server if it is needed, like IIS, Apache, Tomcat, anything. And then on top of this, what we do is we deploy the source code. We deploy the source code and people can access the application. People can access the application. Now, organization will be responsible, XYZ organization will be responsible for managing this physical machine. And this physical machine is what you call it as a server. This physical machine is what we call it as what, guys? Server. One organization, you take any organization, one organization will be generally having multiple such servers in order to manage their daily business needs. Every organization will have many many such servers, not one server. One server will not be sufficient. Every organization will have many servers. How do an organization manage all these servers? Every organization will be having something called as a data center. Every organization will be having something called as a data center through which they manage all the servers. A data center consists of many racks, and racks do contain all the servers located physically. A data center is a building or a dedicated space within a building in which all your servers are located. Every organization will have their own IT team in order to manage these data centers. In order to manage these data centers. If I try to show you in the form of a diagram, maybe it may look something like this. Come to this little later. Now, this is how any organization's data center may look like, where you have racks, and within the racks, physical servers will be there, and all these servers will be connected using a network, and they will have their own right power supply, cooling mechanism, right, security will be there. So it is the responsibility of an organization to manage this data center. This is how data center looks like. When you look at this example where you have one machine, within that machine you have installed some operating system, some dependencies, and then deployed the source code. An organization will have multiple applications. They may develop applications for the same client, or they may be developing the applications for different clients, or even for their internal needs. Organization will have many applications that are up and running. Now, if my organization, assume that if my organization is having 100 web applications, in order to deploy the 100 web applications, do my organization has to purchase 100 physical machines? Do we use one physical machine for deploying one application? Answer is no, we don't do that. We use the same physical machine based on the size, or SKU is what we call it as stock keeping unit. Based on the size of that particular server, we may use that server deploy multiple applications to deploy multiple applications. But the question is, let's say I have two different applications where one application is developed using .NET that targets Windows operating system, and I have another application that is developed that targets Java or Linux operating system. Now, how do I use the same physical machine? How do I use the same physical machine to provide the capabilities where I will be able to install Windows operating system, install the dependencies, and deploy my source code? In the same physical machine, I will be able to install Linux operating system, install the dependencies, and deploy the source code. How do we manage that? That is where there is a concept called as virtualization. If you look at our yesterday's class, the machines what we have created in Azure was not physical machines. We created virtual machines. So what we do is we make use of some concept called as virtualization. Remember, virtualization. We create a virtual system, not actual system, not actual. So what happens is you will have a physical machine. You will have a physical machine. But on top of this physical machine, what we do is we create multiple virtual machines. We create multiple virtual machines with a use of something called as hypervisor. We use something called as hypervisor. A hypervisor is a software that creates and runs multiple virtual machines on a given physical machine. Hypervisor allows one host computer to support multiple guest VMs by sharing its resources. When you say resource, what is a resource? Memory, processing capabilities. So it shares. Right now, you purchase a physical machine. Right, you purchase a physical machine. On top of this, what you do is you may install some host operating system. On top of the host operating system, what we do is we install something called as hypervisor. We install something called as hypervisor. And That hypervisor gives us the flexibilities to install multiple VMs. So these are different VMs assume. If I start naming this, so this is a physical machine. We should understand all these terminologies, guys. On top of this physical machine, what do they install? Host operating system, and then they will install a hypervisor. On top of this, so they will have VMs created. VMs created. Right now, within each VM, you are allowed to create any operating system that you want. They can create any operating system they want, and they can install needed dependencies, and on top of that they can deploy the application. In one VM you may install Unix, in one VM you may install Windows, in one VM you may install CentOS. So it's up to you which OS you install, what dependencies you install, and at the end all these are located on one physical machine. But this OS is what we call it as, so this is called as guest OS. This is called as guest OS. On this guest OS you may install the needed libraries, binaries, and then on top of that you have your application. This is how you manage your applications by using one physical machine. If you feel this physical machine size is exhausted, where you have created many number of VMs, then you will have another physical machine, then you will have another physical machine, then you will have another physical machine, and all these physical machines will be existing in the given data center of an organization. Now, what are the problems of managing this? Now when you have data center in a given organization refers to that physical data center as on premises. So from now onwards, whenever you hear something called as on premises, what do we mean by that? All the servers that are running in our buildings or in our organization data centers are typically referred as on premises. On premise software is installed locally or installed on our computers and servers. That is what you call it as on premises. The moment you get into the cloud, it is important to understand what is on premises. Right? On premises is something that you have it in your local environment, or which is your infrastructure. Maybe you may be managing, or you may have given it to some third party to manage it, but you have the complete control over everything. Then we have something called as cloud. What is cloud? Cloud is another name for internet. Cloud is just another name for internet. Anything that you access over internet becomes a cloud for us. Because cloud refers what? Cloud refers to set of servers that are accessed over internet and the software and the database that runs on those servers. That is what you basically call it as cloud. Cloud servers are located in data centers that are spanned across the globe, which are managed by different providers. Google, your Gmail, documents, videos that you upload into Gmail that are managed by Google Cloud. Amazon videos, what you watch, are managed by AWS. Azure, what we have used yesterday, they are managed by, right, Microsoft. The data centers are there across the globe, but it is immaterial for us. It is immaterial for us. It is the responsibility of the respective cloud service provider to manage all the physical machines, all the data centers. What we just do, we leverage the features. I repeat, cloud is just a metaphor for internet. It is just another name for internet. Now, if you look at this diagram, this is what we tried understanding. You have the infrastructure, on top of that you install host operating system. On the host operating system you install hypervisor, and that hypervisor gives you the flexibility to create multiple VMs, on a given physical machine. And in each VM you install what phase you want, what libraries you want, and then what applications you would want to deploy. In one VM I can install different dependencies, and I can deploy multiple .NET applications in one VM. In one VM I can install multiple Java applications. However you want, you can configure all that. All these VMs will be there on a physical server. Here, alright. Now look at the cloud. So cloud refers, right, something where your softwares or applications or databases are running on some servers. You use internet to access them. Now the process of delivering computing services. When you say computing, yesterday we created a virtual machine, right? That is a server, right? That is a compute service. Cloud computing, we have a concept called as cloud computing. In cloud, you have your servers, and you have, right, your applications and databases are already running on the servers. Now, what is cloud computing? Cloud computing is the delivery of computing services. When I say computing services, what do we mean is the servers, including servers. It can be an application that runs, or it can be a server. Computing services, storage services, network services, analytic services, and we can also add one thing called as intelligence, where into the cloud now artificial intelligence is being added, machine learning is being added. I repeat, cloud computing is the delivery of computing services, storage services, network services, analytic services, and intelligence services over the internet. That means over the cloud, to offer faster innovation, flexible resources, and saves so much of cost. That is what we call it as economies of scale. Economies of scale. Cloud computing allows us to plug into infrastructure via internet and use the computing services or storage services without installing and maintaining them on premises. If you look at yesterday's example, we have created some VMs. Where did we create those VMs? Not in my local system. We created somewhere in the cloud, used the virtual machines for doing some deployment, and when I feel I'm done with that, I have deleted them. So I'll be charged only for the time I use them, only for the resources for the given time use them, I will be charged. I do not have to worry about I do not have to worry about managing those VMs, purchasing multiple VMs based on the need, right? Reducing the VMs, or using databases, or using storage services, or bringing some artificial intelligence, or bringing IoT. I do not have to worry about all of them. It is the responsibility of respective cloud service provider, respective cloud service provider to provide us those facilities. Those facilities. What we do, we just create an account with the cloud service provider, and we will start using the services that are offered by respective cloud service provider, and we will be charged for the services that we use, not more than that. And at the same time, they provide us so many flexibilities. All those we will be understanding when we get into a concept called as cloud computing benefits. When we get into a concept called as cloud computing benefits, we will understand all of them in detail. Cloud computing is on-demand access via internet, computing resources, applications, servers, data storage, development tools, networking capabilities, and many more. And all these are hosted at a remote data center managed by a cloud service provider. I repeat, all these computers, storage, networking, everything is managed by cloud service provider. We have different cloud service providers available in the market, and different cloud providers are AWS, Azure, GCP, Alibaba, Oracle Cloud, IBM Cloud, and the list is huge. The list is huge. Out of all these cloud providers, AWS and Azure are the leading providers in the market. And if I try to show you how much business or what is the market share these cloud providers are having, this is AWS, this is Azure, and then you see different symbols, right? This is basically GCP, and you have Alibaba Cloud and rest all together. Many other clouds, right? So all they together. But now if you look at the major share is with AWS. But what is important for us is look at Azure share in 2017. Look at Azure share in 2021. It is 13% in 2017, whereas it has grown to 22 percentage in the last 4 years, after especially Satya Nadella took over Microsoft's right CEO position. It went very well. It went very well, especially from Azure perspective. Microsoft is going in the right direction, and it is pretty evident that they will lead the market going forward. There are reasons for that. We are confident that they will lead the market in that area, and these numbers are good, right, expected to grow. Microsoft is spending right so many efforts in order to make sure that they gain the top position there. But as of today, this is how the market share is. We use these cloud service providers in order to allow us to make use of cloud computing capabilities or benefit from cloud computing. By using cloud computing, users and companies do not have to manage physical servers themselves. It is managed by the respective cloud provider. We typically pay for cloud services we use that helps us lower operating costs, right? Use the infrastructure more efficiently. Now, just to take our yesterday's example, in our yesterday's class, we have created two VMs. Where did we create those VMs? We used Azure as the cloud service provider and created the VMs. After we are done with that, I have deleted them. But you don't manage these machines. These machines are managed by Azure. Now, question is, when you create a VM, somewhere Microsoft should create that, right? Somewhere it should be created. Like in this example, if your VM can be created on a physical machine. Now, where is this physical machine? Who will manage this physical machine? We do not have to manage that. It is managed by Microsoft. It is managed by Microsoft. Right? Definitely, the VM should have been created in one physical machine that is there somewhere in some data center that is managed by Microsoft. You might be hearing in news that Microsoft is opening a new data center in Hyderabad, or Microsoft is opening a new data center in Chennai, or in Bangalore, or Amazon is opening a new data center. What do you mean by a data center? Right? They purchase some space, they will install, that means they set up the entire data center where they will have all the servers located within the data center. Right. Azure data centers are unique physical buildings. Azure data centers are unique physical buildings located all over the globe. Remember, all over the globe they are located. That house a group of networked computer servers. What is a data center consists of? Data center consists of a group of computer servers where each data center is equipped. Each data center is equipped with independent power, cooling, and networking. Currently, Microsoft is operating their Azure resources in more than 200 data centers, and that number is set to grow. That number is set to grow. Right? So your VMs are created in one of the data center, that is managed by Microsoft. That is managed by Microsoft because we are using Azure. If you use AWS, it is managed by Amazon. But out of all the cloud service providers, it is Microsoft who has more number of data centers than anyone else. Now, I'll ask you a question. Let's say I have an organization, again, same example, XYZ organization, where we are developing an application for a customer called as ABC. We are developing an application for a customer called as ABC. Now, assume that this ABC customer is located in US. Now, when I develop an application for ABC customer, I should place the resources. When I say resource, it is virtual machine, the load balancer, whatever we have used yesterday, that is a resource. So these resources should be placed in what region? My ABC customer expects the resources to be available in US region. So what happens when his customers, right, are when the end users tries to access the application, it should be easy and there should be less latency. It should be very less in terms of latency. Application performance should be very fast. You cannot have customers in India. You cannot deploy your application somewhere around US. You cannot have customers in US and you cannot deploy your application in India. What will be the problem with that? There will be too much of latency. And you have to have the applications located nearby to the users. So what you should do? ABC customer asks XYZ company that you should place all these resources within US. So when you are creating your VM or when you are creating your load balancer or when you are creating your storage or when you are creating a database, you should specify that these resources should be placed in the data centers that are closer, that are there in US, or data centers that are there in India, or data centers that are there in UK. So Microsoft manage things in such a way that you will have region, you will have something called as what? Region. And region will have data centers, right? The data centers are now organized into something called as regions, right? Are divided. So the entire globe they have taken, I'll show you the picture. The entire globe is being taken and they have identified some regions and they will place these data centers across these regions with 60 plus announced regions that are available in 140 countries. Azure makes it easy choice. That means it makes it easy to choose the data center and the regions that are appropriate or relevant for us and for our customers. Using Azure, you get the flexibility to deploy your applications wherever you need. Now, you have a region and region consists of data centers. Right? A region consists of data centers. What Microsoft has done is the actual right high level hierarchy is they have something called as geography, and this geography consists of something called as regions. And the regions, at least as of now, you have understood that you will have data centers, and this is where your physical machines are. Now what is this geography? Right, I mentioned some time back India is a region, but India has more than 130 crores of people. Do you think dividing India into one region will give all the needed facilities like managing data centers, having the complexity, and ensuring that the resources are available all the time? It's not possible. What Microsoft has done is in India, they have three regions. In India, they have three regions. What are the regions? Central India, South India, South Central India. Microsoft has created three different regions in India. Similarly, in US, you have different regions: East US to West US to Central US. Like this, there are different regions. So, in one country, you can have multiple regions based on how much business they are doing, how many resources they are having. Based on that, they divide regions. So, in India, how many regions we have, guys? Three regions. Now, India is what? India is a geography. US is a geography. So, within the geography, you will have regions. And there will be sometimes you will get compliance issues where now you may say, I don't want my country residents' Aadhaar numbers to be stored outside of my geography. That means India citizens' Aadhaar numbers must be stored only in India. You should not store that data in a server that is outside of India. You see such compliance issues. Right? If you have the habit of reading newspapers, or if you follow GDPR or right data leakage issues, there are many things that happens across the globe. So in today's world, what is happening is strictly every organization is asking right the cloud providers to provide the facilities in such a way that if I am a resident of India and if I have some sensitive data, I want my data to be stored only within the servers that are located in India. India is not a region. India is a geography. In India geography, you have multiple regions. So Microsoft can store the data in any region, or Amazon can store the data in any region, but they all should be under India geography. Similarly, US is a geography that has multiple regions. Every region will have many data centers, and in every data center you will have multiple physical machines. When you are, let's say, you are creating storage account, you are creating a storage account where you would want to store some data. You can store the data in such a way that, or you can ask Azure to store the data in such a way that if you create one copy of data, then Azure creates three replicas of the data, and these three replicas can be stored in one data center, or these three replicas can be stored in multiple regions. In multiple regions you can store your data. What is the benefit? If one region is down for any reason, you will get the data from another region, so the data availability will be always high. The data availability will be always high. Let's consider the Ukraine war. Now assume that Ukraine is a region, right? Now the resources in that region is not available. Now if you have created a mechanism, or when you are creating the services or resources, if you specify a mechanism where you want your resources to be stored across the regions within the geography under different regions, let's say for some reason if entire South India is down, if that region is down, then you will get the resources from central India or from south central India. So that kind of flexibility you will get to ensure that high availability, to ensure that high availability. That is a different discussion which we will get into in tomorrow's class. Now, look at this hierarchy. You have a geography, India, in which you have multiple regions like Central India, South Central India, and each region will have some set of data centers. And in every data center, you will have certain physical machines. You will have certain physical machines. But what Microsoft has done is there is a slight modification in this. There is a slight modification. This is not the actual hierarchy. The actual hierarchy is every region is divided into something called as availability zones. Availability zones. They have introduced something called as what? Availability zone. Region will not contain data center. Ideally, regions contains something called as availability zones. And this availability zone consists of data center. Now, why this segregation? Why this segregation? What if my entire data center is down? What if my entire data center is down? That is where this availability zone gives you that flexibility. A region can consist of one or three availability zones, and each availability zone will consist of one or more data centers. One or more data centers. What this availability zone does? See this. This is a region. Within the region, you will have multiple availability zones. You will have multiple availability zones where each availability zone is a physical separate location within the given region that are tolerant to local failures. Failure can be a hardware failure, failure can be a software failure, or it can be a flood, it can be a fire, or it can be earthquake. So When Microsoft tries to set up these availability zones, they consider things in such a way that if some problem occurs here, if some problem occurs here, to the maximum extent, that same problem, chances of same problem occurring in this location is very less. If it occurs here, the chances of that same problem occurring here are very less. But at the same time, they ensure that all these are connected internally using fiber optical cables. All these availability zones are connected using fiber optical cables, and the latency will be very less at any given point of time. You should, if one zone is down for some time, Azure uses an algorithm in such a way that they'll get you the data from other zone. The latency will be less than 2 milliseconds. That is how they choose these locations. When they are setting up these availability zones, as I said, one Azure region can consist of one or three availability zones. And when they consider create three availability zones, they ensure that these availability zones latency is less than milliseconds, so that it it allows customers to get the data in very less time, right? And data is always available, and your applications are fault resistant. If some problem occurs, you can be confident that your data will come from other availability zone that is still up and running. So you had to do all that configuration. So there is something called as LRS, ZRS, GRS, ZZRS. So all these different combinations like local redundant storage, zone redundant storage, geographic geo redundant storage. Like this, you have different storage options available. We'll be discussing about all of them. How Microsoft chooses these availability zones is very simple. Latency between these two should be less than 2 milliseconds. That means if this zone is down, I should be able to quickly go to the other zone and get the data, and the time should not be more than 2 milliseconds. Imagine that, 2 milliseconds, guys. So customers will not find any latency issues. That is how they choose. So when we created a VM, that VM is created in some data center that is in some zone of given region which comes under a geography. Just to make things interesting for you, what I can do is I can open an infrastructure map, guys. Infrastructure map of Microsoft. It'll take some time, but a beautiful diagram, guys. It's a globe. In the meantime, remember this: geography. India is one geography. US is one geography. Like this, there are multiple geographies. I'll explain you what are all the geographies, what are all the regions. So you have region, you have availability zones. One region can consist either one or three availability zones. And then every zone can consist of one or more data centers. And every data center will have a set of servers. So you can see here it has come up here. Now you see here guys, basically this is West US. So I'll allow that to rotate so that when the India one comes, right? This is the globe. So now India one will come. So I'll take you to that first and then I'll show you the other things as well. Right. So if you keep here, it is Malaysia. So you see this is Taiwan. Right? This is China. Now you get India. Now you see this is India. This is geography. They have different regions. Central India, South India, South Central India. Now here you have your data centers, Nagpur, right? So Bombay, they are in Coimbatore, and one will be coming up in Hyderabad soon. So that is how they have organized. Now if you see here, this is Malaysia, where they have multiple data centers. Right? Now you see, if you observe, all these data centers are connected through cables, guys. All these are connected to cables across the oceans. Fiber optic cables to ensure that latency will be very less. And what is more interesting as here, if you see here, you can work with it however you want it. So now you see here they have, right, wind farms. What they do is to ensure that we maintain clean environment in order to provide the power for the data centers. What Microsoft has done is they have created their own energy centers where they generate the power by using, you see, these wind farms. You see here so many you have energy centers, solar, wind, whatever is possible, right? Now they use these energy centers to generate the power that is needed to manage your infrastructure, that is needed to manage the infrastructure, so that we are using sustainable energy, right? We are not causing any harm to the environment, to ensure that Microsoft uses their own, right, energy centers. That is what you could see. So you see everything well here, all connected through cables, right? You have everything. Africa, they don't have much client base. That is where you don't see many regions, many things. Wherever they'll have more client base, obviously they'll set up more things there. So here they have more. This is Europe and this is US. You see United States, Canada. That is one geography. This is one geography. In this geography, you have many regions: Central US, North Central US, right? Canada Central. Canada is US to you have. See, you can go through this globe base. It gives you so much of understanding of the hierarchy that we had discussed. So yesterday when we have created a VM, the VM is created in a data center of a given region, You can select availability zones also, in which availability zone you want your VM to be created, but that is something I'll explain you little later. These regions are grouped into geography. Right. I'll stop my discussion here, and then it's time to clarify your doubts, and you can ask your doubts, guys, now.